Okay, so for this question, we're given a binary search tree denoted by T, and then we also have a path length, which is just a counter. So just using some examples, if you look at 42 here, this is technically a leaf node because it doesn't have any children, and a leaf node occurs when there's no more children here, so this is technically pointing to null. Same with 54 here, 98, etc. So using 42 as an example, we start from the root, that's at level 0, and then we move to the left, and then we move to the right. So it's doing technically two moves here, so from 0, 1, and then another 1. So the way I've done this is we're going to write a helper function to help us out here. So this is going to be just a similar name, count leaves. And then it's also going to take in this binary search tree. T, it's going to have a int current length. And then it's also going to have the original path length. Cool. Sorry about my layout here. It's a little bit messed up due to my tiling manager. It won't let me drag the windows out anymore. So we've kind of got our struct definitions in this header file I was given for the question. And there's obviously C implementation for all of this as well, but I've just kind of left it as a bit of a reference here. Okay, so let's think about the base case. So if the tree is empty, it means that the count is going to be 0. So we want to return 0 here. Okay. So T is empty. Now we want to check if T to the left is equal to null and T to the right is also null. Okay, so what this is doing here is we'll add recursion a little bit later, but this is just saying if this is the case for if the node doesn't have any children whatsoever. So yeah, if in the 42's case, if we go left and it's got nothing, and also if we go right and it's got nothing, that's a child node. And then we also want to compare our current length if it's greater than, I guess we could have greater than or equal, but I'm just going to do greater than our path length. Current length equals path length. Okay, so now we want to do our recursive case. So I'm going to have a left count here, and this is going to equal our function, and then it's going to count everything to the left. It's going to go left, and then we want to return the current count plus 1, and the path length as well. So we're going to do the exact same thing here for the right count. Equals count leaves. So T right, current length plus 1. And path length. And then what we're actually going to return here is the left count plus right count. So I'm not doing the best job explaining this. I just want to see if I can get it right. maybe in the future I might upload some better style videos. Okay, so I actually haven't ran anything. I've just been trying to kind of write what I remember. So here's where we want to return the count leaves function. And we need to put 3 different parameters in here. So we want to put the binary search tree T, and then we want to do start with the count at 0, and then what is this in path length? And we also want to put in path length as well. I'm just going to remove this if statement. Okay, so if the current length is greater than or equal to this path length, which is at 0, we want to return 1. Else we just want to return return 0. Auto test. Okay, this looks like it worked. Okay, so here's my solution. Not very good. I'll see if I can crop this